Okay, 7th grade. I would like to talk to you a little bit about what you're going to be doing in class today. As you know, you're getting some class time to work on your Station 2 write-up. Please check the assignments for any details. For Station 2, you need to be using the entire class data as your resource for your results. And you should be comparing materials that were adjacent to each other. But still, there's a lot to be said about things that ended up being a lot hotter than other things and why. Then actually you're going to be, if you do finish that, you're going to be working on Station 3. So Station 3 was something that that I did and I talked to you about in class, where just up on the balcony, you know, where our potting area is, I put a brick and a piece of wood, and I brought a LabQuest up there with some surface probes, and we put one of the surface probes on the back of the wood, one on the back of the brick, and one just underneath a little bit of the soil. And we faced the brick and the wood so it's kind of facing out towards the balcony area. And we ran the experiment actually for more than 24 hours, actually more than 36 hours, I think, so that we encompassed like a night and then a full day and then another night, just so we could really see patterns. And we did the surface temperature was taken every 10 minutes. We also put a light probe out there so that we could see what happened with the light. So this station right here is downloadable on the topics page on Keysnet, and it has information and some questions to think about. And then you'll see in the email that I have emailed you this file. And this is a LabQuest file. It should open up with LabQuest. As you can see in here, the red is the brick, and the blue is the wood, and the green is the soil in this top graph. And down here, this is the light probe that was going on at the same time. So there's a lot of stuff that we can analyze here. We can analyze why the light started to increase here, and then why it went down here, and why it was starting to increase again at the end. We can analyze why these temperatures were dropping and kind of bottomed out right here, and then why they started to rise again here, and then why they fell again to end up pretty low down here. So very interesting stuff in terms of just the general patterns. But then we could look at some very specific stuff, and I just want to show you how you can do this. You can take a specific area and you can highlight it, and you can press the plus to zoom in, and you can really analyze which things were heating faster, which things were heating slower. And you just press the minus button and you can end up back here. If you do something and you totally mess up, you can always just quit Logger Pro, right? Don't save when you quit, and if you open it up again, it'll be just like this. So that's the, you know, if you get to that place. Now you can also look at kind of what's happening in the cooling down phase. So if I look at kind of this bit of the graph, like what's going on, and I can look at, you know, where things were when they were at their hottest, and then what happened as they cooled down, which things cooled down faster, which things cooled down slower. Just again, trying to understand things a little bit more deeply. So you really want to talk about all of those patterns and how they relate to the light probe information, and then get down to the nitty-gritty of why. So zooming in and out of different parts of the graph and trying to figure out what's going on. And in here, there's always, you know, your results. You summarize your results in one paragraph, and so the results would be talking about the patterns in here, which things heat up faster, cool down faster, etc. And then in the subsequent paragraphs, you are theorizing, right? So when you're theorizing, you can consider the following questions, like when and why are the materials heating and cooling? Why does the light probe data, what does the light probe data show? What surface cools down the fastest or the slowest? What surface heats up the slowest or the fastest? How does the soil figure into it all? Why does it take longer for a material to cool or heat? And what is going on with the molecules? So all kinds of ideas that you can contemplate as you write up your results and discussion. Now, they're not due until next week. Again, look at the Keysnet assignments. Look at the Keysnet topics page to get all the information you need. but you should be working very focused for the entire class. Thanks very much. Good luck.